You're standing in what used to be your neighbor's front yard. The wind is still moving through the trees, but the trees are gone. So is the house, so is the car that was parked in the driveway. The roof of your own place is somewhere half a mile down the road, wrapped around a telephone pole, and you're staring at the only thing left standing on this entire street. A white concrete dome, no windows broken, no cracks, the front door still latched. Inside, a family is making coffee like it's a Tuesday morning, because for them, it basically is. That dome cost about $500 in materials per occupant when it was built. The houses around it cost $200,000 each, and right now, in this exact second, in real counties across Alabama, Oklahoma, and Texas, this is happening. The Pensacola Beach dome home survived Hurricane Ivan in 2004, while the houses on either side were reduced to splinters. The Monolithic Dome Institute in Italy, Texas, has documented over 100 cases just like it. EF 5 tornadoes, Category 5 hurricanes, wildfires that turned entire towns into ash. The domes walked away. And here's the part that's going to bother you. In most states in this country, you are not legally allowed to build one as your primary residence. Not because it's dangerous, because it's too cheap, too efficient, and it doesn't fit the code. I'm going to walk you through exactly why this $500 concrete shell outperforms a $1 million bunker, why the building departments quietly hate it, and the one specific mistake that turns a life-saving dome into a death trap. Stay with me, because halfway through this, you're going to realize something uncomfortable about the house you're sitting in right now. Let's start with the thing that nobody tells you. The dome isn't new. It isn't experimental. It's been around since 1975, when a man named David South in Idaho built the first monolithic concrete dome using an inflated airform, a layer of polyurethane foam, rebar, and shotcrete sprayed from the inside. That's the whole recipe. You inflate a giant balloon, you spray foam on the inside, you wire up rebar, you shoot concrete over the rebar, you deflate the balloon. You have a building that will outlive your great-grandchildren. The Federal Emergency Management Agency, FEMA, has officially classified properly built monolithic domes as near absolute protection from tornadoes and hurricanes. That's not marketing language. That's a federal designation, FEMA P361 and FEMA 320. The actual standards for storm shelters in the United States recognize the monolithic dome as capable of withstanding 250 mile-per-hour winds and impact from a 15-pound 2x4 traveling at 100 miles per hour. Try that on your stick frame house. The 2x4 goes through your wall like it's wet cardboard. Now ask yourself something. If this thing is federally recognized, cheaper to build, cheaper to heat, cheaper to cool, and survives what nothing else survives, why have you never seen one in your neighborhood? Hold that question. We're coming back to it. And if you're already thinking what I think you're thinking, that maybe the house you're in right now isn't actually built for the world we're living in, then stick with me and subscribe, because the next part is where most people get this completely wrong and end up spending 50 grand on a bunker that would have failed in the same storm. Drop me a comment right now. Tell me what your house is made of. Wood frame, brick veneer, manufactured. I want to see what we're working with here, because by the end of this video, you're going to look at those walls a little differently. Here's where the bunker crowd gets uncomfortable. A standard underground concrete bunker, the kind you see advertised for $40, $50, sometimes $200,000, has a fundamental design problem that the dome solves by accident. Bunkers are rectangular, or they're cylindrical tubes buried sideways. Both shapes concentrate stress at corners and seams. When the ground above shifts, when water table pressure builds up, when a shock wave hits, that stress finds the weakest joint and tears it open. There are documented cases from the Cold War era of Titan II missile silo support structures built by the United States Air Force with reinforced concrete walls 8 feet thick that still developed catastrophic cracks at the corner joints after decades of pressure cycling. 8 feet of concrete, corners failed. The dome has no corners, none. A monolithic dome distributes load across its entire surface uniformly. Push on any point and the force travels around the whole shell. This is the same principle that lets an eggshell, which you can crack with your fingernail from the side, support the weight of a grown man when you press straight down on the ends. Geometry beats mass, always. The Dome of the Rock in Jerusalem has been standing since the year 691. The Pantheon in Rome, unreinforced concrete dome, has been standing since 126 AD, 1900 years. Through earthquakes, through fires, through wars, through the fall of the Roman Empire itself. Your bunker manufacturer is offering you a 50-year warranty on a steel tube. You see the gap. And here's what really gets me. The dome doesn't just survive better, it costs less to survive. A 400 square foot emergency dome shelter, the kind you can build with a small crew in about a week, runs roughly $3,000 to $4,000 in total materials according to current Monolithic Dome Institute pricing. A residential dome, 1,200 square feet, fully finished, has been built for under $60,000 by owner builders in Texas and Arizona. That's a house, a real federally storm-rated house for the price of a mid-sized pickup truck. So why is this banned? Let me be careful with that word, because it's not technically a ban in most cases. It's worse than a ban. It's a slow strangulation through code. In 37 states, residential building codes are written around stick frame and masonry construction. The codes specify rectangular foundation requirements, standard truss systems, conventional roof pitches, and setback measurements that assume a box. A dome doesn't fit any of it. So when you go to the permit office in most counties and you say, I'd like to build a monolithic concrete dome as my primary residence, the response isn't no. The response is, we don't have a category for that, which means your application sits. And sits, some jurisdictions require an engineered stamp from a structural engineer who has specifically certified dome construction, and there are maybe 200 of those in the entire country. Homeowners associations forbid them outright in covenants because they don't look like the neighbors. Mortgage lenders won't finance them because there are no comparable sales for appraisal. Insurance companies charge punishing premiums or refuse coverage entirely, despite the structure being objectively safer because their actuarial tables don't have a column for buildings that don't fail. Florida had a brief window in the early 2000s where dome construction boomed after Hurricane Andrew. Then the code tightened. Texas still allows it in unincorporated counties, which is where most of the famous ones, including the Italy, Texas headquarters, and the Sundance Mountain School, actually exist. Outside city limits, outside the reach of the codes designed for boxes, the pattern is the same everywhere. The further you get from a planning department, the more likely you are to find a dome standing. Now here's the mistake, the one that turns this whole thing from miracle to tragedy: ventilation. I want you to remember this. If you build a sealed concrete dome and you don't engineer the airflow correctly, you will suffocate in your own shelter. This is not theoretical. The Monolithic Dome Institute keeps records of incidents where owner-builders sealed up their shelters without proper passive ventilation stacks and lost consciousness within hours during the first real test. A monolithic dome is essentially airtight by design. That's part of why it's so energy efficient, why people heat 1,200 square foot domes in winter with a single space heater. But airtight cuts both ways. Carbon dioxide builds up, oxygen depletes, humidity climbs, mold follows. The fix is not complicated, but it has to be done right. You need cross ventilation at minimum, ideally a passive intake low and an exhaust stack high to use natural convection. And for any shelter intended for sustained occupancy, you need a filtered mechanical system with backup power. The numbers matter. A single adult at rest consumes roughly 15 to 20 cubic feet of air per hour and exhales carbon dioxide at a rate that becomes dangerous in an unventilated space of 200 cubic feet in about 6 hours. 6 hours. That's the gap between a perfect shelter and a tomb. Most people building these on YouTube tutorials never mention this. They show you the airform, they show you the rebar. They never tell you that the same geometry that keeps the tornado out keeps your last breath in. Look, if you've made it this far into the video, you're not the kind of person who's going to forget what I just said. You're thinking ahead. You're already running the numbers on your own property, on your own family, on what it would actually take to build something that doesn't get blown apart the next time the sky turns green. Everything I'm walking you through here, the exact dome diameters for different occupancy levels, the rebar spacing and gauge that meets FEMA P361, the shotcrete thickness charts, the airform suppliers that ship to all 50 states, the passive ventilation stack designs that prevent the carbon dioxide problem I just described, the county-by-county breakdown of where you can actually permit one of these without a 6-month fight, the owner-builder cost spreadsheets, the wiring and plumbing routing that works inside a curved wall. All of it is in the manual, step-by-step, diagrams included, links in the description. If you're serious about this and not just watching for entertainment, that's where you go next. Let me give you one more piece, because I want you to leave this video with something you can actually use tomorrow. The most successful dome builds in the United States right now, the ones that pass inspection, get insured, and end up costing the owner less than $50,000 finished, all share 3 traits. First, they're built in counties without a residential code enforcement office or in agricultural zones where ancillary structure rules apply. Second, they're sized between 16 and 24 feet in diameter for shelters or 30 to 40 feet for residences, because that range hits the sweet spot of structural efficiency and material cost. Third, they're built by the owner with hired help only for the shotcrete phase, because that's the one part you cannot do alone and cannot fake. Spraying concrete at the right pressure, the right thickness, in the right pattern requires a crew with real equipment and real experience. Everything else, the airform setup, the foam, the rebar tying, the finishing, you can learn from documentation. The shotcrete you hire out for one day, that single day, usually $2,000 to $4,000 depending on dome size, is the difference between a structure that lasts a century and one that delaminates in a decade. So here's where we are. You have a building method that survives what nothing else survives. That costs a fraction of what you've been told a safe house costs. That uses geometry instead of mass to defeat the worst weather on the planet. And the only reason most of you have never seen one is that the system that profits from rebuilding your stick frame house every 15 years has no incentive to let you out of the cycle. You can stay in the box, or you can think in curves. If you want to know which county near you allows this construction with the least friction, drop the name of your state in the comments and I'll pull the data for the next video. And if there's a specific structure, an underground complex, a sealed facility, a forgotten Cold War site you want me to break down next, tell me. I read every one. And remember what I told you about the ventilation. The dome will save your life, but only if you build the air in before you seal the walls. Think about what that means on a practical timeline. The first modern monolithic dome, built by the brothers in 1976 in Shelley, Idaho, a potato storage facility roughly 105 feet across, is still standing today, still in use, still holding its original shape after nearly 5 decades of freeze-thaw cycles that would have buckled a conventional steel building twice over. David, Barry, and Randy South filed the foundational patent on the airform construction method in 1979, and what they discovered almost by accident was that the inflated membrane created a compound curve so structurally efficient that the concrete shell only needed to be about 3 inches thick at the crown to outperform a 16-inch poured wall. 3 inches? That's the thickness of a hardcover book, and it will stop an EF5 tornado carrying a 2x4 at 250 miles per hour, which Texas Tech's Wind Engineering Research Center verified in their debris cannon tests back in 2004. The projectile shattered, the dome surface showed a 1/4-inch indentation, no penetration, no spalling on the interior face, no structural compromise. Compare that to a standard residential wall, which the same cannon punches through like wet cardboard at 100 miles per hour. Now, consider the fire data. In 2003, during the Cedar Fire in San Diego County, a monolithic dome home in the Crest neighborhood survived a direct burnover that destroyed 313 surrounding houses. The owners returned to find their patio furniture incinerated, the metal mailbox melted into slag, and the dome itself completely intact with the interior at room temperature. No smoke infiltration because the sealed airform skin doesn't allow ember intrusion through soffits or attic vents, which is how 90% of houses actually ignite during wildfires. They don't burn from radiant heat, they burn from embers crawling into hidden cavities. A dome has no cavities. And yet, the counter-argument deserves a fair hearing. Domes are not for everyone. The interior layout demands creativity, because you cannot frame a standard rectangular room against a curved wall without losing usable floor space, sometimes 15 to 20% of the footprint at the perimeter. Resale value can be unpredictable in markets where buyers expect colonial floor plans and granite islands. Lenders, as I mentioned earlier, sometimes refuse to write conventional mortgages on non-standard construction, which means you may need to bring more cash to the table or work with a credit union that specializes in alternative builds. Insurance companies occasionally classify domes as commercial structures, even when used as residences, which can complicate your premium calculations. These are real friction points. I won't pretend otherwise. But weigh them against the alternative. A 30-year mortgage on a stick frame house in a tornado corridor, a wildfire zone, a hurricane coast, where the statistical probability of total loss within the loan term keeps climbing every year. The climate data gets updated. The insurance industry already knows premiums in Florida have tripled since 2019.